Hello everyone, welcome to another exciting video. Here in this video we're going to talk about radioactivity, and we are going to focus on the ionizing effect of radiation. I'm sure you must be wondering, radioactivity, how does that connect to me? Well, I must tell you that the sun that maintains the life processes is an evidence of radiation. In fact, we are exposed to so much background radiation via the radioactive materials in the rocks, in surrounding air, in our bodies. And in fact, once you move outside of the earth into our solar system, we can start talking about the exposure we get from cosmic rays. All right, now the forerunners, these two people you have on your screen, they've done so well in expanding our knowledge of what radioactivity is. In fact, they were the ones that made the first set of observations. The first person on the cards is Henry Becquerel. In 1896, he observed that uranium substances emits radioactive materials, and those materials affected a photographic plate, even though it was wrapped in a black paper. He didn't really know much about it, but he just made the observation accidentally. He found it accidentally. Some years down the line, Marie Curie, in her research, discovered a lot more about radioactivity and even found a second substance that can be radioactive, which is radium. She worked with radium. In fact, she was the one that coined the word radioactivity. Now, radiation can either occur naturally or it can be artificially stimulated. He noticed, that's Henry Becquerel, in his accidental observation, like I said earlier, that radioactive materials also ionize gases. Now, when we say ionize gases, that means it knocks off electrons from the molecules of the gas. When you bring a lighted match close to an electroscope, let's say this electroscope is negatively charged, the lighted match knocks off electrons from the surrounding air. Now, let's say this is uranium attached to a faucet. The uranium as well, once it gets close to the electroscope, it knocks off electrons from the surrounding air. Now, since the electroscope is positively charged, it attracts the electrons that were knocked off in the first instance to itself. Then it becomes neutralized. And the same thing happens to our other guy here. The electroscope, the cap, is negatively charged. Since electrons have been knocked off from the surrounding air by this lighted match, the negatively charged cap attracts the positive ions to itself, thereby neutralizing it. So in both cases, the cap of the electroscope is neutralized. Thank you very much. Bye, and I will see you in the next video.